So, welcome back. Now we are going to talk about hydrostatic pressure on rectangular submerged surface. So, why are we talking about a generic rectangular submerged surface? Because we have to understand certain concepts, and we are going to establish certain ideas of solving pressure plates, how they are formed. Now, you have to understand there is something called gauge pressure. Then there is something called differential pressures, different types of pressure. Now, one of the most common thing is called a gauge pressure. So when you stand in an atmosphere, a gauge pressure is going to give you a pressure of the atmosphere that is 0.101 megapascals or 101.235 kilopascals. This is your atmosphere. This is the pressure that atmosphere is creating around your skin. I'm sure you guys are very strong and young teenagers or early 20s. If you go to a market and you buy a ketchup bottle or jam bottle or sometimes your favorite drink, and it takes a lot of force to open, and sometimes you're applying all your force and the bottle cap is not opening. That is because the atmosphere is applying pressure, since there has been certain vacuum generated within the bottle. So the best way is to warm your bottle a little bit, and what will happen is those gases inside it are going to create a specific pressure that can generate an equilibrium between the atmospheric pressure and the pressure inside the bottle. But if the bottle pressure decreases inside the bottle, then atmosphere is going to apply force on the cap. As a result, no matter how much you apply force, it's not going to open unless you create an equilibrium of pressure across the bottle cap. So that is just one phenomena that you must see or observe in your day-to-day life based on aerostatic pressure. That is how much air can apply force on you. And your muscle densities, your bone densities are different. The more you will go to the equator, the higher pressure is on your bodies, on your entire surface. As a result, your muscle density increases. Your body has a higher muscle density. That's why people near the equator are a little thinner compared to people at the north. They are taller, they are fatter, because atmosphere does not apply much pressure on them. As a result, their body grows at a normal density, but the strength goes to the people at the equator. Atmospheric pressure increases. Not significantly, but significant enough. Similarly, let's come back to our topic. As other than concerned topic, let's come back to the original topic. That is, what does water do? So, if you are concerned that you need to develop more exercise, if you're living by a river or a lake, then I think you better start swimming. You can have a better muscle tone density. That's a little help tip there. Now, let's solve this problem. If you have a large rectangular surface or square surface and you put it in water, what will happen? This is something you have to understand. If your surface is very, very large, let's say you take 1 meter square, 1 meter by 1 meter in an area of a square plate, and you put it in the water, then you're going to see two things. Number one, the surface, the edge that is closer to the surface would have lower pressure compared to the edges at the depth of the water, because previously we derived an equation that says change in pressure is equal to, for a homogeneous mixture of density rho, under the action of gravitational force with G, there is going to be change in pressure directly proportional to the depth, that is delta H. The deeper you go into the water, the more you put your plate into the water, the more pressure at the bottom part will increase and less pressure will be at the top part. So how are we going to generalize this phenomenon? So where would be the resultant of this entire pressure H on my plate? So a rectangular surface, this surface is easy to start with. What you do is you take your surface and your tank and your container and your plate, and you turn it into a two-dimensional system right here, like is shown, x, y, and x. This is important. What is for this thing? Z. This is Z. X is coming out of the string. Positive x, that is. And if you look at this thing, you have a right angle triangle from point B right here. Take a straight line 1, 5, and this is a triangle. Now, how did we get this triangle? Very simple. You don't need to find the value of b. We all know the value of b. That would be the sorry. It is difficult to handle without a proper tool. So we are doing it with mouse. So you have to forgive me for inconveniences what you're going to see through. But I hope you can use your imagination. It's the best power you have. Now, what we have is a triangle, like I said, 1, 5, 6, 1, 5b. I get back to 1. That's the one right angle triangle. But you don't have the information what is at B, and you don't need that information. We are going to stick to what we have. You have a trapezoid that is 1, 2, 6, and 5. 1, right here. You go to 2, and you go to 6, and then you do 5. Now, what is the magnitude of these arrows? Simple, rho g h. You have got the density of water, you got the gravitational field you're working in, and you got the depth. That is how much deep you're going, right straight down. You don't need much, straight down. It will give you the magnitude. This much pressure is acting on 2, and if you take further down, it has to be a straight line. At 1, you'll get the magnitude of the force acting on point 1 based on simple laws of pressure. Now, once you got this thing and you introduce and start drawing, what you see, this would, since it is 1 is deeper than 2, it will have a high magnitude force, and 2 is much closer to the surface with low magnitude force, and you draw a trapezoid. Now, once you have drawn the trapezoid, you know that at certain position it is keep on going and become 0. Pressure will become 0, and that is where your point B exists. Now you have got a right angle triangle. As you all know, the depth or the center of the right angle triangle exists where? 1/3 of the distance from the base. Simple mathematics. And that is where your R works. Now this is one way to go through, which I have introduced for you. It's a very, very simple way, but for this particular technique, you need to know that your system or your geometry is ready. Now let us look at a certain other type. When suppose this plate becomes very, 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 very small. This means the distance between 1 and 2 becomes so small that it becomes almost negligible, and the length of B, that is distance between 2 to 3, that is defined as B, is very large. You cannot ignore this distance. Then you have to find a 3-dimensional position. So how do we find this position? So in order to find a resultant R, you need to know B. Everybody there, it's a right angle triangle, it's a squared surface, so you got the value of B. Then you have integrate from A to A prime. So what is the value of A prime? As you all know, A prime is difference. He is going to the same maths what I'm giving you right here. Rho G H A R, and you're going to find again the moment about Y, then you're going to find the moment about x-axis, moment about y-axis, and moment about z-axis, and then this equation is going to be only for y prime. Then you're going to get it for x prime. Sorry, it's going to be x over dA. Then you're going to get it for z prime, and you're going to get 3-dimensional position. Now, let me regroup the entire information that we have so far. Number 1, we can use simple geometric representation to find the center R, the resultant R, where it is working from 2-dimensional system to 3-dimensional system. Or we can use a simple technique where we can find the average value of pressure and use this technique of integration from known surface to surface, slicing, introducing your area into 2-dimensional system, taking a very small slice, that is dy times B, to form the area, and you can use that information to generate your reaction, or you can say resultant R force problem. So this is what you will get in the final, that my resultant R is defined as P average, where P average is what? Rho G H. H is to be taken to the average height right in between, and A is the area for which it is working. The two techniques are there, but my preference would be if you use a simple trapezoidal phenomenon. uh, sorry, sometimes things get disturbed. So let's give it a recap. In order to find the resultant R is the combined effect of this pressure acting on this plate. For this rectangular plate, you have taken a very, very small section dy with B. So you can say my A prime is in fact defined as this area, D times P magnitude. Now, if you look at this area, this is simple dy times the average P. So what is P average? You take this P, upper P, lower P and divide it by 2. So you can say P1 plus P2 and you divide it by 2. This is your area times dy, right? And you put this P average, and if you find the value of P average, what you know is that rho is constant, G is constant, the only thing that is changing is H. H1 plus H2 divided by 2, the average height. And this depth is going to be this height times this height. So imagine you introduce a limiting factor and you say limit, that's this height is going to very, very close to 0. As a result, your dy is going to become very, very, very small. As a result, your dA is going to be negligible. Assuming that h1 it becomes so close, that dy becomes so small that your h1 is approaching h2 or h2 is approaching h1. This means if they are approaching, then the difference is so small that it is going to be either one of them. So rho gh will become constant and A will become again a fixed volume, fixed area. Right? As a result, if you take this dA and you need to find the value of y, how do you find it? You're going to add all the areas, add them together, and you will find the resultant. So your integration will go from 1 to 2 based on height. And this is where you will find in a two-dimensional system your reaction R. Now you have to find at what depth. When you have found y, you need to find x. This is important. So in order to find x, what you do is you take this surface and you look it from the other side. That is from the front side. What you will see is it is just a square. That is it. And the only thing you need is where it is located, and you find since it is square, it has to be at the center of the two. At the center, that is b by 2. This is just for a rectangular or squared surface. This is a surface area.